The requirements planning engineers place on complex heating, ventilation and air conditioning plants are very demanding. A high level of operating safety, long service life, service friendliness and efficiency are of prime importance. Large volumetric flows are to be controlled with great accuracy. In addition, excellent control performance is expected, plus product variants that permit tailored solutions, and all this at affordable prices. These demanding requirements for actuating devices do not pose any problem to the planning engineer because he knows the products to use that easily satisfy such requirements. The Aquatics valves and actuators of the electro-hydraulic line from Siemens, and he knows why. Single-seat stroke valves can be used thanks to the great positioning forces delivered by their electro-hydraulic actuators. Owing to the design principle of these valves, volumetric flows with enormous pressures and high temperatures can be controlled reliably and with great accuracy. Depending on the type of application, differential pressures up to 12 bar at static pressures up to 40 bar can occur, corresponding to a water pressure at a depth of 400 meters. At a differential pressure of 12 bar, the water passes the valve's throttling path at a speed of nearly 50 meters per second. If due to a defect in the plant, the valve needs to shut off against a static pressure of 40 bar, the speed will reach 89 meters per second, comparable with the top speed of a Formula 1 racing car. Yes, you heard correctly. Even at high differential pressures and temperatures up to 220 degrees Celsius, with thermal oil even up to 350 degrees Celsius, Aquatics valves are capable of reliably controlling and shutting off high volumetric flows. To ensure the control valves satisfy these demanding requirements, they are made of high-quality materials that warrant a long and maintenance-free service life. Stem, plug and seat are made of high-grade stainless steel. The flow chambers are designed to ensure optimum flow conditions, eliminating annoying noise. The perforated, notched and parabolic plugs, developed by Siemens, produce accurate valve characteristics. Large travel enables a fine resolution, a prerequisite for optimum control performance in HVAC plants. Stroke valves with metal-to-metal seating are suited for universal use and have very low leakage rates under the aforementioned conditions regarding pressure, media and temperature, from 0 to a maximum of 0.02% of the kVs value. They also ensure accurate control under low load conditions. Aquatics stroke valves are designed such that in combination with electro-hydraulic actuators, they can close either against the pressure or with the pressure. As 3-port valves, they can be used as mixing or diverting valves. Practical experience shows stroke valves with metal-to-metal seating from Siemens operate very reliably at extreme pressure differentials, large volumetric flows, and high temperatures. They show almost no signs of wear and tear and offer a very long service life. To be able to make full use of the benefits offered by these valves, great positioning forces are required. Here, Siemens brings the electro-hydraulic drive principle into play. Hydraulic systems deliver enormous forces while consuming only little energy. They have proven their worth in millions of applications in the aircraft industry and in the fields of construction machinery and hoisting and conveying equipment. What's more, the hydraulic concept is very simple. Forces are transferred directly and fast with no need for using gear trains. As a result, only a few moving parts are required and there is hardly wear and tear. So why not make use of hydraulics to generate great positioning forces? This idea of Siemens engineers led to the development of Aquatics actuators type SKD, SKB and SKC. And these are the components contained in the actuator's housing: console, cylinder, piston, oil pump and return valve, and as the key element, the return spring. The return spring is always compressed, enabling it to pull the valve stem into the fully closed position at any time without requiring energy from outside. The force produced by the spring reaches a maximum of 2,800 newtons, which is more than the world record in heavyweight lifting. The control valve is opened by the hydraulic system. The tiny pump pumps hydraulic oil from the suction chamber to the pressure chamber. The spring is further compressed and the valve opens. The small oscillating pump, a Siemens development, is the heart of the hydraulic acvatics actuators. With a power consumption of just 8 watts, it delivers positioning forces of more than 10,000 newtons, safely, reliably, and with no wear and tear. During the valve's closing movement, the oil returns to the suction chamber via the return valve, and the mechanical force stored in the return spring closes the valve. Oh, a power failure. This can happen also in the case of a complex heating plant. No reason to worry. The design concept offers a spring return feature in a very elegant and straightforward way. Other types of actuators can only offer this facility as a costly extra function and with much lower positioning forces. And this is how it works. In the event of a power failure, the energy stored in the spring is released via a second return valve, closing the control valve within 10 or 20 seconds, with a force of 1,000 and 2,800 newtons respectively. Only Siemens can do this. In spite of low energy consumption, the actuator operates fast and accurately. Depending on the requirements, the running time is 120 or 30 seconds for the entire stroke, the resolution being less than 1%. The control signals required for handling the enormous driving forces are delivered by the newly developed Advanced Control Technology, or ACT electronics for short. Extensive automation and easy-to-understand control enhance flexibility and safety. Standard features: automatic identification of stroke and end position, simple diagnostics through LED status indication, selection of optimum control characteristics, can be controlled by standard control signals DC 0 to 10 volts or 4 to 20 milliamperes. Checkback signal indicating valve position. Forced control, for example, frost protection function. The following extra functions are available as options: adjustable starting point and operating ranges, for example for sequencing, or stroke limitation for output reduction. Signal reversal for motorizing valves with reversed operating action. More than 2 million electrohydraulic acvatics actuating devices have proven their worth in a wide variety of applications worldwide. Clearly, engineers and planners use the electrohydraulic line wherever large amounts of energy in the form of high pressures and volumes need to be accurately controlled, where highest safety is a key criterion, and where comfort, service friendliness, and reliability are of great importance. Everywhere, with success.